Now let's consider the case where we have a hydrocarbon with an alkene in it. We've already seen that if we treat cyclohexene, for example, with bromine, the alkene will be substituted to form the dibromide in an electrophilic substitution reaction. But what if we want to install a bromine in this compound in a radical halogenation fashion instead? We can't simply use bromine to do this. Instead, we use a reagent called NBS. NBS is N-bromosuccinimide and is a reagent shown at the bottom of the slide. And under the reaction conditions, NBS serves as a source for the slow formation of bromine radical. The bromine radical then abstracts the weakest CH bond in the molecule, the allylic CH bond next to the alkene. And based on the mechanism that we've seen for radical reactions, take a moment and see if you can draw the propagation and termination steps for this radical reaction, knowing that bromine radical is formed. The bromine radical will abstract the weakest CH bond in the molecule. That's the CH bond next to the alkene. Abstracting that hydrogen will form an allylic radical. And remember that allylic radicals are resonance stabilized, so they're some of the most stable radicals. The allylic radical then reacts with bromine to form the new carbon-bromine bond at the position next to the alkene, and to generate an equivalent of bromine radical. And you might be asking yourself, where did that bromine, that Br2, come from? And we'll see in a moment that it's generated in another step in this reaction. And one step to be aware of that is unique to these reactions of NBS is the reaction of NBS with HBr. Remember that we generated HBr in the first step of the reaction. Well, NBS reacts with HBr to form the amine, or the imide, here, along with Br2, bromine. And this bromine is then available for reaction with the allylic radical. Similarly, the bromine radical formed in the reaction step is available to react with cyclohexene and abstract a hydrogen atom from the CH bond. And finally, I want you to remember that in a radical reaction, many or all of the reaction steps are occurring simultaneously. These steps aren't sequential like they are in polar reactions. Let's end this video with a quick concept check. What products would be expected from the radical reactions shown? The first step of a bromination reaction with NBS is the formation of bromine radical from the NBS. Once a bromine radical is formed, it will abstract the hydrogen from the weakest CH bond, and the weakest CH bond will always be the one next to the alkene. Abstraction of this hydrogen forms the allylic radical. And remember that the allylic radical is stabilized by resonance. That's what makes it such a stable radical. Well, that resonance means that there's radical character at both of the positions. And that means that both of those carbons, both of the resonance forms, will react with bromine to form new carbon-bromine bonds. So this reaction will form a mixture of these two products, one with the tertiary bromine and the other with the primary bromine. And the second product, the primary bromine product, will form in greater amounts. It will be the major product because it's the more stable alkene. So remember that more substituted alkenes are more stable alkenes, and those will form in greater amounts in these radical bromination reactions. We'll end this video series with the question we saw at the beginning, to determine the products for each of the halogenation reactions shown. First, treating the methyl cyclohexene with chlorine under conditions of light irradiation will lead to a radical halogenation reaction, a radical chlorination reaction. And then remember that radical chlorination reactions are not selective, and will form all possible constitutional isomers of monochlorination. So I like to identify the unique CH bonds and then draw each of the corresponding chlorination products. And here there are 5, corresponding to the 5 unique CH bonds in the starting material. In the second reaction, where there is no light irradiation, the bromine will react with the alkene in an electrophilic addition pathway. Remember that this is the reaction of an alkene with bromine that proceeds through a bromonium ion intermediate to form the dibromide. And the dibromide forms with anti-stereochemistry. And if you need to, go back and review those electrophilic addition reactions to make sure you're comfortable with how they proceed and how they're different from these radical bromination reactions. Finally, in the third reaction, the NBS will provide radical bromination at the allylic position, the weakest CH bond. And here we have 2 allylic CH bonds that are different, so both radicals will form. And each resulting allylic radical has a resonance structure. So in this case, although we say it's a selective reaction, in fact 4 different bromination products will form. And of these 4 products, the one with the most substituted alkene will form as the major product. But here, in this case, all of the alkenes are disubstituted, so all will form here in nearly equal amounts.